Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. Yeah. So, people, let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly, let me know in the chats with some fire emojis. Yeah. Quickly, let me know in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible, visible to everyone. Good evening, people. Good evening and welcome back. Good evening and welcome back. Well, we are meeting after so long, yeah? I believe, after 3 months. After 3 months, I'm going to take the academic session on this particular channel. Well, this is going to be the first session, right? So, people, let me know in the chats if all of you are super duper excited about this new journey of NEET 2026 with your Unacademy NEET English team. Yeah? Quickly. Quickly, people, everybody in the chats. All right, absolutely. JEE main students can also watch this session. NEET students, JEE main students, whosoever wants to watch, you're most welcome. So before starting the session, let me know which part of country you guys are watching me from right now. I want to know from which state you guys belong to. I want to know this in the chats first of all. I want to know this in the chats first of all. Let me see from where the majority is. I want to see from where the majority is. All right, Kerala, Tamil Nadu, Kashmir. Wow, nice. Tamil Nadu, Andhra Pradesh, Karnataka, Hyderabad. All right. Pondicherry. Wow. Meghalaya, Assam. United States of Pulwama. Okay. Nice. All right. Perfect, perfect, perfect. Someone is watching from Saudi. Wow. Perfect, guys. So, first of all, let me give you the quick context of this particular series, which we are starting today. Okay. My dear students, in this particular series, the level up series, which I'm calling, first of all, this particular series is going to be for all the NEET 2026 aspirants. If you are even the NEET 2027 aspirant, you can watch it. If you are the JEE aspirant, you can also watch it, right? Because as you can see, the name of the series, it's going to be the level up series for the NEET and JEE aspirants. Perfect. And in this particular series, I will be completing your entire physical chemistry as well as your inorganic chemistry of your class 11th as well as class 12th. Okay? Right here on this particular channel. Perfect. And at the same time, all the session PDFs, everything I'll be sharing on my Telegram. If you are not the part of my Telegram channel yet, be the part of the Telegram channel right now. It is Wassim Bhat Chemistry Official. WASSIMBHAT Chemistry Official. That is the name of the Telegram channel, right? Wherein I'll be sharing the handwritten session PDFs. After every chapter, I'll be sharing the DPPs, the question practice, every single thing I'll be sharing there on my personal Telegram channel. Okay? But people, I would want you guys to be like committed, dedicated, right? I'm going to be dedicated for sure. Perfect. I want you guys to be dedicated as well. And one more amazing thing, every session, whatever session I'll be taking on over here on this particular channel, it's not going to be the one shot. I'll be completing every chapter in like 3 to 4 sessions. I'll take 3 to 4 sessions to complete every chapter, right? And the session duration of every session is going to be almost 2.5 hours, 3 hours, like that. Okay? And this series is going to be very easy for you as well. How come it's going to be easy? Because, for example, today I'm coming on the channel. Tomorrow it's going to be Ambika ma'am who will be coming, then HSP sir, then Yavar sir, then again me, right? So one day, one session, 2.5 hours, good level up content which you need at this particular point of time. Okay? Perfect. Should we start the session then? Are you all ready? Are you all ready, people? Yes, I'll be starting exactly from the basics. I'll be starting exactly from the scratch. As if you have never studied the chapter before. Don't worry. Well, basically today's session is only about completing the basics. Today's session is only about completing the basics. So don't worry about that. Should we start then? Organic chemistry will be taken care by HSP, sir. I might take some of the chapters of organic as well. Let's see that. Okay. I might take some of the sessions of organic as well. You need not to worry. Still, guys, don't worry. Don't worry. All right. All right. All right. All right. Let's get going. Let's get started. And my dear students, today we shall be starting with the first chapter of your class 11th physical chemistry. We shall be starting exactly from the first chapter of your class 11th physical chemistry. Just give me a second. Let me fix certain things. Let me fix certain things and we shall start. Just give me a second. Okay. So people, all the things are going to be handwritten. All the questions are going to be handwritten, right? Perfect. So as I told you, we shall be starting from the first chapter of your class 11th physical chemistry. And you know, the name of the chapter is Some Basic Concepts of Chemistry. The name of the chapter is Some Basic Concepts of Chemistry. Some Basic Concepts of Chemistry. Either you call this chapter as Some Basic Concepts of Chemistry, or my dear students, the other name for this particular chapter is the epic mole concept. One of the amazing chapters of physical chemistry, and a lot of students, they find this particular chapter difficult, but I'm telling you one thing, if you are following all the sessions of mole concept here from this particular channel, right after completing the chapter, you will be in a position to solve each and every question from the mole concept, from whatever study material you solve, whatever is going to be your study material which you'll be solving, right? While after completing the chapter here on this particular channel, take any study material, try it out. I believe you will be in a position to solve each and every question of your study material, right? Perfect, people. So let's get going then. Let's get started directly with the first concept, with the first topic that I am going to cover here. That is going to be your atomic mass. The first basic terminology with which I shall be starting the chapter. Atomic mass. My dear students, first of all, how do we exactly define the term atomic mass? How do we exactly define the term atomic mass? Someone is saying, sir, fix the camera properly. Is the camera not fixed properly? I think it's okay only. Okay, let me do it after the session. It's okay. It's the first session, so don't worry. Let me fix it afterwards. Periodic classification, I'll be taking care on the channel. Okay. Just give me a second. Let me fix the camera once. Just a second. I don't want any mess in the first session itself. Just a second, guys. I think it should be fine now. It should be fine now. Yes, this series is free. Yes, absolutely. It should be fine now. Is it? Perfect, guys. So let's get going down. Let's get started. So the first topic which I shall be covering in the today's session, what is that going to be? That's going to be your atomic mass. My dear students, how do we define the term atomic mass in very simple terms? Let me write the simplest definition of it. Atomic mass is nothing but it is defined as the mass of one atom of an element. Mass of one atom of an element. Whatever is going to be the mass of one atom of an element, that is something which you will be calling as the atomic mass of an element. For example, you take any element. Let's say you are taking carbon and you are asking me, sir, what is the atomic mass of carbon? I'm asking you in reverse, what does that mean? What do you mean by atomic mass of carbon? That means you are talking about the mass of one atom of carbon. For example, I'm asking you, what is the atomic mass of boron? What does that mean? That means I'm asking you, what is the mass of one atom of boron? For example, I'm asking you to calculate the atomic mass of sodium. What does that mean? That means I'm asking you to calculate the mass of one atom of sodium. Okay? For example, I'm asking you to calculate the atomic mass of magnesium. That means I'm asking you to calculate the mass of one atom of magnesium. So atomic mass is nothing but it is the mass of one atom of an element. Okay? It is the mass of one atom of an element. Now, my dear students, in order to know the actual significance of atomic mass, in order to understand this particular topic in very depth, very detail, I have to talk about certain basic things here. And what are those basic things? Let's get to know. See, guys. For example, let's say, just to make you understand, let's say I'm taking some two objects here. Let's say I've taken two objects here. Object number one, object number two. Okay. So first of all, let's assume that this particular object, its weight is, for example, 5 kilograms. The weight of the first object is 5 kilograms. The second object which we have, let's assume its weight is, for example, 10 kilograms. Just to make you understand. I've taken two objects. The weight of the first object is 5 kilograms. The weight of the second object is 10 kilograms. Right? Now, my dear students, can I do just a simple thing? Can I break this 5 kilograms as 5 multiplied by 1 kg? Absolutely, I can do that. Because 5 multiplied by 1 kg eventually will come out to be 5 kg only. Yeah? Similarly, my dear students, 10 kg I can break as 10 multiplied by 1 kg. Because 10 multiplied by 1 kg will eventually come out to be 10 kg only. So I have taken two objects here. The weight of the first object is 5 kilograms. The weight of the second object is 10 kilograms, right? I have broken down this 5 kg as 5 into 1 kg. I have broken down this 10 kg as 10 multiplied by 1 kg. Now the point is, why did I do that? Why did I break this 5 kg like this? Why did I break this 10 kg like this? There's a logic behind that. What logic exactly? Say, guys. Can I say this particular object, can I say this object is 5 times heavier than 1 kilogram? Yes. This particular object is 5 times heavier than 1 kilogram, right? Similarly, this particular object, my dear students, the second object, can I say it is 10 times heavier than 1 kilogram? Absolutely. This object is 10 times heavier than 1 kilogram. For example, my weight is 85 kilograms. What does that mean? That means I am 85 times heavier than 1 kilogram. Correct? So can I say, I am comparing the masses of different objects. I'm comparing the weights of different objects with this 1 kilogram. I'm comparing the weights of different objects with this 1 kilogram here. As I said, this object is 5 times heavier than 1 kilogram. The second object is 10 times heavier than 1 kilogram. I am 85 times heavier than 1 kilogram. So basically, I'm comparing the weights of different objects with what? I'm comparing the weights of different objects with 1 kilogram. Right? So this 1 kilogram here, my dear students, this 1 kilogram with which I'm comparing the weights of different objects. This 1 kilogram with which I'm comparing the weights of different objects. I'm calling this 1 kilogram as the standard. I'm calling this 1 kilogram as the standard, or I can call it as the reference as well. The one with which you will be comparing certain things. The one with which you'll be comparing certain things, you call that as the standard or reference. So 1 kg is my reference. 1 kg is my reference with which I compare the weights of different objects. Perfect. Now, my dear students, you know, in chemistry, we do not deal with bigger sized objects. We deal with small particles, right? We deal with small particles. We deal with atoms. We deal with electrons. We deal with molecules, something like that, right? So first of all, as you saw, I was comparing the masses of different objects with this 1 kilogram. In chemistry, since we deal with atoms, we deal with molecules, We deal with ions. So can I say in chemistry, we should also have a standard. We should also have a reference with which I shall be comparing the masses of different atoms or molecules, right? I can say in chemistry, we definitely need a standard. In chemistry, we need a reference with which we should be comparing the masses of different atoms or molecules. Now, what is that standard? What is that reference in chemistry? Let's try to make that standard. Let's try to make that reference. And my dear students, in order to make the standard, in order to make the reference, what I'll be doing exactly? I will be taking a carbon 12 atom. I will be taking a carbon 12 atom. Okay? I'll be taking a carbon 12 atom. For example, just to make you understand, let's say this is your carbon 12 atom. Okay? This is your carbon 12 atom. The carbon 12 atom which I've taken over here, what exactly am I going to do? I'm going to divide this carbon 12 atom into 12 equal parts. I divided the carbon 12 atom into 12 equal parts. Okay? After dividing the carbon 12 atom into 12 equal parts, if I take one part of it, and if I ask you what is the weight of this shaded part, you will say the weight of this shaded part is nothing but it's going to be 1 by 12. It is going to be 1 by 12th of the mass of carbon 12 atom. It is going to be 1 by 12th of the mass of carbon 12 atom, right? It is going to be 1 by 12th of the mass of carbon 12 atom. Now, my dear students, this 1 by 12th of the mass of carbon 12 atom, this 1 by 12th of mass of carbon 12 atom, this term from now onwards, you will be either calling it as 1 AMU, or you will be calling this term as 1U, or you will be calling this term as 1D. Now, what is the meaning of this AMU? What is the meaning of this U? What is the meaning of this D? Let me make it clear to you. My dear students, AMU stands for the atomic mass unit. AMU stands for the atomic mass unit. Okay? This term U over here, it stands for the unified mass. It stands for the unified mass. And this D over here, it stands for what? It stands for Dalton. This AMU stands for atomic mass unit. U stands for unified mass. D stands for Dalton. So what exactly I did? I am going to make a standard in chemistry with which I shall be comparing the masses of different atoms or molecules. To make that standard, I took a carbon 12 atom. I divided the carbon 12 atom into 12 equal parts. After dividing the carbon 12 atom into 12 equal parts, I just took one part of it, and the mass of this part is nothing but 1 by 12th of mass of carbon 12 atom, and the mass of 1 by 12th of carbon 12 atom is going to be called as 1 AMU or 1 U or 1 D. AMU stands for atomic mass unit, U stands for unified mass, and D stands for Dalton, right? Now, people, let me tell you one more thing. There was a technique called as mass spectrometry. There was a technique called as mass spectrometry. And with the help of the technique called as mass spectrometry, what scientists exactly did? They calculated the mass of the entire carbon 12 atom. And let me tell you, the mass of entire carbon 12 atom, it came out to be 1.99 into 10 raised power minus 23 grams. The mass of the entire carbon 12 atom, it came out to be how much? The mass of entire carbon 12 atom came out to be 1.99 into 10 raised power minus 23 grams. Perfect. Now, if we know the mass of entire carbon 12 atom, can we get the mass of the shaded part as well? Yes, we can get the mass of shaded part as well. So what do we need to do exactly? We need to divide this particular term. We need to divide this particular term with what? With the number 12. When you divide this particular term with the number 12, the value exactly comes out to be 1.66 into 10 raised power minus 24 grams. Perfect. The value comes out to be 1.66 into 10 raised power minus 24 grams. Now, if I ask you whether this is the mass of entire carbon 12 atom, you will say no, this is not the mass of entire carbon 12 atom. You will say this particular term, it is the mass of the shaded part over here. This is the mass of 1 by 12th of the carbon 12 atom in grams. Yeah? Right, people? Perfect. And remember, from now onwards, this 1.66 into 10 raised power minus 24, you are going to write it as 1 divided by Avogadro's number. When 1 is divided with Avogadro's number, When 1 is divided with Avogadro's number, when 1 is divided with 6.022 into 10 raised power 23, you get the value exactly as 1.66 into 10 raised power minus 24. When 1 is divided with 6.022 into 10 raised power 23, you get the value exactly as 1.66 into 10 raised power minus 24. So my dear students, let me quickly summarize all of this in just one statement, which I want you guys to remember from now onwards. What is that particular statement? Have a look. I'm going to define one AMU. One AMU is also called as 1U, and 1U is also called as 1D. How do you define this 1D? It is simply defined as 1 by 12th of the mass of carbon 12 atom. 1 by 12th of the mass of carbon 12 atom. Its value in grams came out to be 1.66 into 10 raised power minus 24 grams, which in terms of Avogadro's number came out to be 1 divided by Na grams. Perfect. Let me know once in the chats if this particular statement is clear to you or not. Quickly, let me know in the chats, people. This lecture will be for 2 hours. Don't worry. It's going to be a 2-hour session. Let me know in the chats quickly if this is clear. Let me know quickly in the chats if this is clear. Everybody. Everybody, people. Perfect. Perfect, guys. All right. Yes, Phoenix 3.0 students can also listen to this. Yes, why not? Yes, yoga, this is going to be enough. All right. So, my dear students, let's try to have a look on certain more things. For example, now I'm writing a statement. Atomic mass of oxygen. If I ask you what that means, atomic mass of oxygen, what does that mean? That means I'm talking about the mass of one atom of oxygen. That means I'm talking about the mass of one atom of oxygen. And my dear students, if you know, the mass of one atom of oxygen is nothing but, it is 16 AMU. It is 16 AMU. Now what I can do exactly is, I can break this 16 AMU as 16 multiplied by 1 AMU, right? Instead of 1 AMU, I can write 1 by 12th of the mass of carbon 12 atom. And instead of the same 1 AMU, what I can write? I can write 1.66 into 10 raised power minus 24 grams. And even instead of this 1 AMU, I can write 1 divided by Na grams. Perfectly done. Yes. So people, have a look on these particular terms. Have a look on these particular terms. Have a look on why I did all this stuff here. Just try to understand what is the meaning of all these terms which are mentioned over here on your screen. See, first of all, I'm defining the term atomic mass of oxygen. That means I'm talking about the mass of one atom of oxygen. I'm talking about the mass of one atom of oxygen. And the mass of one atom of oxygen, it came out to be how much? It came out to be 16 AMU. What does that mean? That means one atom of oxygen is 16 times heavier than 1 AMU. One atom of oxygen is 16 times heavier than 1 AMU, right? One atom of oxygen is 16 times heavier than mass of 1 by 12th of mass of carbon 12 atom. One atom of oxygen is 16 times heavier than 1 by 12th of mass of carbon 12 atom. I would say this is basically the mass of one oxygen atom in grams. Even this is the mass of one oxygen atom, but it's in AMU. This is the mass of one oxygen atom in grams. Even this is the mass of one oxygen atom in grams, right? Am I clear, people? Am I clear? Am I clear? Let me take one more statement which makes things more clear to you. For example, I'm writing a term, atomic mass of sodium. I'm writing a term, atomic mass of sodium. First of all, what does that mean? Atomic mass of sodium. It means that we are talking about the mass of one atom of sodium. Now you must be knowing what is the mass of one atom of sodium. What is the atomic mass of sodium? It is nothing but 23 AMU. My dear students, 23 AMU can be broken down as 23 multiplied by 1 AMU, right? My dear students, instead of 1 AMU, I can write 1 by 12th of the mass of carbon-12 atom. Instead of 1 AMU, I can write 1.66 into 10 raised power minus 24 grams. Instead of same 1 AMU, I can write 1 divided by Avogadro's number in grams. I believe this is clear to everyone, right? So people, what was I writing? I wrote a term, atomic mass of sodium. That means I'm talking about the mass of one atom of sodium. I'm talking about the mass of one atom of sodium, right? My dear students, one atom of sodium is 23 times heavier than 1 AMU. One atom of sodium is 23 times heavier than 1 AMU. One atom of sodium is 23 times heavier than 1 by 12th of mass of carbon-12 atom, right? We say this is the mass of one sodium atom in grams. Even this is the mass of one sodium atom in grams. Perfect. So if I ask you now, what kind of information this atomic mass is giving us? What kind of information this atomic mass is giving us? I would say atomic mass is nothing. It is just telling me how many times an atom of an element. It is just telling me that how many times an atom of an element is heavier than what? Is heavier than 1 AMU. As you could see, one atom of oxygen is 16 times heavier than 1 AMU. One atom of sodium is 23 times heavier than 1 AMU. One atom of nitrogen will be 14 times heavier than 1 AMU. So atomic mass is just giving me the idea that how many times an atom of an element is heavier than 1 AMU. So I can write this in the form of the statement. Statement is pretty much simple. I can say atomic mass of an element. Atomic mass of an element gives an idea about. Gives an idea about how many times an atom of an element, how many times an atom of an element is heavier than 1 AMU. If I'm clear with this, let me know once in the chats quickly. If you understood the term atomic mass, let me know quickly in the chats, people. Yes, Nimbus students can also watch this, absolutely. Let me know quickly in the chats, people, if this particular term is very, very much clear to every one of you. I want to know in the chats first, everyone in the chats. Everyone in the chats. Yeah? Perfect. Perfectly done. Perfectly done. Perfectly done, guys. Now, there are few things which I would want to let you know, right? You can remember those terms. They'll be they'll be useful to us, basically. See, guys. For example, I'm taking an element nitrogen. Let's say I'm taking an element nitrogen, okay? The element which I've taken over here, that's nitrogen. For nitrogen, let me do one thing. Let me write few things about nitrogen. The first thing which I'm writing about nitrogen is 14 AMU. This is the first term which I'm writing. The second term about nitrogen is just 14 without any units. Without any units. The third term which I'm going to write, instead of 14 AMU, I'm writing 14 multiplied by 1 AMU. And instead of that 1 AMU, I'm writing 1.66 into 10 raised power minus 24 grams. Right? Let me tell you, what is this particular term? What is this 14 AMU? This is the atomic mass of nitrogen. This is the atomic mass of nitrogen. This is the mass of one atom of nitrogen in AMU. In AMU. This is the mass of one atom of nitrogen in AMU, right? This 14, only 14 without the units. You'll be calling this as the relative atomic mass of nitrogen. You'll be calling this as the relative atomic mass of nitrogen. And this particular term, 14 into something, this entire term is what we call as the actual mass. This is basically the actual mass of nitrogen. Or you can say this is the mass of one nitrogen atom in what? In grams. This is the mass of one nitrogen atom in grams. This is the mass of one nitrogen in AMU. This is the mass of one nitrogen atom in grams, my dear students. Okay? Somebody was texting me, sir, I could not find your Telegram channel. The name of the Telegram channel is Wassim bhat, chemistry, official. This is the name of the Telegram channel, if you are unable to find it, okay? This is the name of the Telegram channel. So join in as soon as possible. Wassim Bhat, chemistry official is the name of the Telegram channel. Okay, I'm moving ahead, people. I'm moving ahead. All right, I'm asking you one simple question. Let me see if you can answer this or not. One simple and basic question I'm asking you. Calculate the mass of 10 nitrogen atoms. Calculate the mass of 10 nitrogen atoms. Number 1, in AMU. Number 2, in grams. Number 3, in kilograms. Give it a try. Give it a try, people. Give it a try. Yeah? Give it a try quick. I want the answers from everyone. I want the answers from everyone. All right, let's have a look. Let's have a look, guys. It's a pretty simple question. Let's see how exactly it's to be solved. Calculate the mass of 10 nitrogen atoms in AMU, in grams, in kilograms. So, my dear students, if I talk about one nitrogen atom, what is the mass of one nitrogen atom in AMU? The mass of one nitrogen atom in AMU is 1 AMU. What is the mass of one nitrogen atom in grams? It is 14 multiplied by 1.66 into 10 raised power minus 24 grams. This is the mass of one nitrogen atom in grams. What is the mass of one nitrogen atom in kilograms? It is 14 multiplied by 1.66 into 10 raised power minus 24 divided by 1000. So it comes out to be 10 raised power minus 27. It comes out to be 10 raised power minus 27 kilograms. Correct? This is the general information about one atom of nitrogen. It is the general information about one atom of nitrogen. Now, people, we are done. If the mass of one nitrogen atom is 14 AMU, therefore the mass of 10 atoms of nitrogen, the mass of 10 atoms of nitrogen will be 14 into 10, which comes out to be 140 AMU. Right? Similarly, 14 into 10 comes out to be 140 multiplied by 1.66 into 10 raised power minus 24 grams. Similarly, it's going to be 140 into 1.66 into 10 raised power minus 27 kilograms. If I'm clear with this, let me know once in the chats, my dear students. Let me know once the chats if this is super clear to everyone. Yeah? Quickly. Quickly, people. For mole concept, there is no need to study the NCERT. You can just do the questions of NCERT once the chapter is done. Just the questions of NCERT. No need to go for the theory and stuff in the mole concept chapter. Okay? Perfectly done, people? Perfectly done? Just give me a second. Guys, just give me a second, okay? Just give me a second. Yes, yes, the series will continue. Yes, don't worry. Series will continue. All right, let's move on. So I believe your atomic mass concept is clear, right? So I'm moving on, my dear students, to one more concept which you would have studied somewhere, I believe. Anyways, I'll be starting from the basics only. What is that? That is molecular mass. As I told you in the today's session, I'll be covering the basic terminologies. Basic terminologies only. Molecular mass. How do we exactly define the term molecular mass? How do we exactly define the term molecular mass? In simple words, my dear students, I can define molecular mass as the mass of one molecule. The mass of one molecule of any substance. The mass of one molecule of any substance is what you call as the molecular mass. Mass of one molecule of any substance is what you call as molecular mass. Or it can be defined as the sum of it can be defined as the sum of atomic masses of all the atoms. The sum of atomic masses of all the atoms of all the elements present in a molecule. The sum of atomic masses of all the atoms of all the elements present in a molecule. For example, have a look. Let's say, my dear students, I'm talking about water. Let's say I'm talking about water. If I ask you what is the molecular form of water, I believe all of you would be knowing already. The molecular form of water is H2O. Now I want to calculate the molecular mass of water. What does that mean? That means I want to calculate the mass of one molecule of water. Now the point is, how do we calculate the mass of one molecule of water? How do we exactly calculate the mass of one molecule of water? My dear students, start with hydrogen. What is the atomic mass of hydrogen? 1 AMU. How many hydrogen atoms do you see? 2. What is the atomic mass of oxygen? 16 AMU. How many oxygen atoms do you see? 1. The value comes out to be 18U. You can write either 18 AMU, or you can write 18U, or you can write 18D. But remember, in terms of molecules, in case of molecules, preferably we use the term U. In case of the molecules, preferable term is U. You can write 18 AMU, you can write 18D, right? You can write 18U. Preferably, what do we write? We write 18U. All right? Now, people, can I break this 18U as 18 multiplied by 1U? Absolutely. I can break this 18U as 18 multiplied by 1U. Instead of 1U, can I write 1 by 12th of the mass of carbon to an atom? Yes, I can do that. My dear students, instead of 1U, can I write 18 multiplied by? Instead of 1U, can I write 1.66 into 10 raised power minus 24 grams? I can do that. Again, 18 multiplied by, instead of 1U, can I write 1 divided by Na grams? Yes, we can do that too. Now, people, try to understand the meaning of all these terms. 18U, or 18 multiplied by 1U, or 18 multiplied by 1/12 of this, or 18 multiplied by this, or 18 multiplied by this. What is the meaning of all these terms? You should know first of all. So people, I'm talking about the mass of one water molecule. I'm talking about the molecular mass of water. Molecular mass of water means mass of one molecule of water. And we got to know the mass of one molecule of water is 18U. Or you can say one molecule of water is 18 times heavier than 1U. One molecule of water is 18 times heavier than 1U. Or I can say one water molecule is 18 times heavier than 1 by 12th of mass of carbon to an atom. 1 by 12th of mass of carbon to an atom. Or I can say this is the mass of one water molecule in grams, right? Even this is the mass of one water molecule in grams, right? Perfect. सर कश्मीरी में पढ़ाओ कश्मीर पे पढ़ना वाब मगर इमन कही समझ कश्मीर पे पढ़ना वाब तो तक मैं पढ़ना हूं नु तक तो बोझुन या ओके all right I believe this is clear I believe this is clear I believe this is clear. Yeah? Yes, this is the first class of the chapter. This is the first class of the chapter. Okay? Perfect, guys. All right, let's move on. Now, what exactly am I doing? Let me again write one more statement just to make you understand things. Let me write ammonia here. I believe every one of you would be familiar with the term ammonia, right? What is the formula for ammonia? The formula for ammonia is NH3, right? Is NH3. My dear students, I want to calculate the molecular mass of ammonia. What does that mean? That means I want to calculate the mass of one molecule of ammonia. I want to calculate the mass of one molecule of ammonia. And how do we exactly calculate it? How do we exactly calculate the mass of one molecule of ammonia? See guys, pretty much simple. Start with nitrogen. What is the atomic mass of nitrogen? 17 AMU. How many nitrogen atoms do you see? 1. Sorry, not 17. What is the mass of one atom of nitrogen? That is 14 AMU. How many nitrogen atoms do you see? 1. What is the mass of one atom of hydrogen? 1 AMU. 3 hydrogen atoms. The value after solving comes out to be 17U. This 17U I can break as 17 multiplied by 1U. Instead of 1U, I can write 1 by 12th of mass of carbon 12 atom. Instead of 1U, I can write 1.66 into 10 raised power minus 24 grams. And instead of this 1U, you can write 1 divided by Na grams as well. Perfect. So my dear students, if you look at these terms, see, we are trying to calculate the molecular mass of ammonia. That means we are trying to calculate the mass of one molecule of ammonia. And the mass of one molecule of ammonia came out to be 17U. What does that mean? What does that mean? What does that mean? That means one ammonia molecule is 17 times heavier than 1U. One ammonia molecule is 17 times heavier than 1 by 12th of mass of carbon 12 atom. Right? And my dear students, this is the mass of one ammonia molecule in grams. Even this is the mass of one ammonia molecule in grams. So if I ask you, what kind of information this molecular mass is giving us? What kind of information this molecular mass is giving us? They say molecular mass is just giving us one simple information. How many times a molecule is heavier than 1 AMU or 1U, right? Perfect. Right? So people, I can write a statement then. I believe this is clear. And the statement is pretty much simple. I can say the molecular mass of the substance gives an idea about how many times a molecule is heavier than either you want to say 1 AMU or you can say 1U. The choice is all yours. Perfect. I believe this is clear to everyone. And if this is clear, my dear students, then there are few more things which I would want to tell you right now. And what are those things? Let's have a look. Here what I'm doing exactly, I'm writing N2. I'm writing N2. Earlier I wrote N. I took nitrogen earlier in atomic form. Now, right here, I'm not taking nitrogen in atomic form. I'm taking nitrogen in molecular form. I'm taking nitrogen in which form? I'm taking nitrogen in molecular form. I'm taking N2 here, right? I'm taking N2 here. Now, my dear students, I can write the first thing as 28U. 14 into 2 is 28. 28U. The second term is just 28. The third term is 28 multiplied by 1.66 into 10 raised power minus 24 grams. If I ask you what is the meaning of all of them? What is the meaning of all these terminologies? What is the meaning of all these terminologies? This 28U is what you call as molecular mass of nitrogen. So basically, it is the mass of one molecule of nitrogen. It is the mass of one molecule of nitrogen, yeah? This is what you call as a relative. This is what you call as the relative molecular mass of nitrogen. Relative molecular mass of nitrogen. And this particular term, this is something which you call as the actual mass of N2. Actual mass of N2. Or I can say one more thing. This is the mass of one nitrogen molecule in U. Even this is the mass of one nitrogen molecule, but in grams. Perfect? Perfect, people? Now, if I give you one simple question, or before giving you the question, okay, let me give you the question first, then I'll tell you one more statement. The simple question I'm giving you, let me see if you can solve this or not. I'm asking you to calculate the mass of 10 oxygen molecules, not oxygen atoms, oxygen molecules in number 1, AMU, number 2, grams, number 3, kilograms. Can you give it a try? Tell me its answer quickly. Quickly, people. Quickly in the chats. Everybody. Everybody. Exactly, guys. See, it's pretty much simple. If I ask you about 1 molecule of O2, what is the mass of one O2 molecule? It's going to be 16 into 2. That comes out to be 32. AMU or 32U? Choice is all yours. In terms of grams, it's going to be 32 multiplied by 1.66 into 10 raised power minus 24 grams. In terms of kg, it's going to be 32 into 1.66 into 10 raised power minus 27 kilograms. Perfect. Till now, I was talking about the mass of one molecule of O2. But am I supposed to calculate the mass of one molecule of O2? No. I want to calculate the mass of 10 molecules of O2. So what about the mass of 10 molecules of O2? I'll say 10 molecules of O2 will have the mass of 320U. It's going to be 320 multiplied by 1.66 into 10 raised power minus 24 grams. It's going to be 320 multiplied by 1.66 into 10 raised power minus 27 kilograms. Perfect. So this is something I was supposed to calculate. I believe this is clear to everyone. That's a urge krit. Kashir put khulbu channel lak. ठीक है? Kashir channel lak khulbu zaruri. That was parno kashir put. ठीक? When diman bicharan parni man nebriman. Next channel is me in kashir put. Marvin kis me karta spam chat and muskya. Sidhe me kis man ba ke nebriman parna at least, huh? Okay. So people, am I clear to everyone? Am I clear to everyone? No, no, this was not Hindi. This was Kashmiri. This was Kashmiri, yeah. So there was a guy asking me whether you will be starting any channel in Kashmiri language. I said, don't spam right now. I'll be doing that. Okay. Let others study first. All right. Should I move on? Should I move on, people? Should I move on? Let me know in the chats quick. Everybody. Everybody, people. No, no. Sir is kosher. Sir is kosher. Questions we are going to do in some time, okay? Questions will be done in some time. Let's cover up certain basic things first. Well, you can write all this. You can write in U as well, AMU as well, D as well. The choice is all yours. The choice is all yours. Okay? I'm moving on, people. I'm moving on. Yes, Yavar sir will be taking your physics. Yes. All right, people. Now here I'm writing a statement. Okay, remember that statement. That's very important. What is that statement? Statement is pretty much simple, but remember it. Statement is on changing the standard. On changing the standard. Actual mass of the substance, on changing the standard, actual mass of the substance does not change. So the standard which we have chosen, if you remember, the standard which we have chosen, what was that? We defined 1 AMU as 1 by 12th of mass of carbon-12 atom. We defined 1 AMU as 1 by 12th of mass of carbon-12 atom. Now, what if we define 1 AMU as 1 by 6th of mass of carbon-12 atom, 1 by 24th, 1 by 36th of the mass of carbon-12 atom? What will happen to the actual mass of the substance? My dear students, when you change the standard, nothing happens to the actual mass of the substance. Nothing. Okay? Have a look. Let me solve a few questions so that you can understand all the stuff in detail. I'm starting with the first question. Understand properly what I'll be doing. Let's say the question is, if 1 AMU, or instead of AMU, let me use the term U. If 1 U is defined as, 1 by 24th, of the mass of carbon-12 atom. If 1 U is defined as 1 by 24th of the mass of carbon-12 atom. Calculate the molecular mass of carbon dioxide as per new scale. Also calculate the actual mass of carbon dioxide. Also calculate the actual mass of carbon dioxide. That is the question. That is the question. See, my dear students, how this sort of equation is to be solved. See how this sort of equation is to be solved. First of all, how have we defined 1U already? We have defined 1U as 1 by 12th of mass of carbon to an atom. This is how we have defined 1U. This is how we have defined 1U. Let me call this equation number 1. Now, as per the question, they are changing the standard. They are changing the standard. They are defining 1U as, which I'm calling as 1U dash. They are defining it as 1 by 24th of the mass of carbon to an atom. 1 by 24th of the mass of carbon to an atom, right? I'm calling this equation number 2. Perfect. My dear students, we have defined 1U as 1 by 12th of mass of carbon to an atom. As per the question, they have defined 1U as 1 by 24th of the mass of carbon to an atom. Now, as per the question, do we have to calculate? Do we have to calculate the molecular mass of carbon dioxide as per U or U dash? We have to calculate molecular mass of carbon dioxide as per the new scale, as per U dash. Okay. So what is the first thing which I'll be doing in order to solve these questions? My dear students, the first thing that I'll be doing is divide the two equations to get the relation between U and U dash. Divide the two equations to get the relation between U and U dash. How exactly I'll be doing? I'll be dividing equation 1 with equation 2. When I divide 1 with 2, it becomes U divided by U dash. U divided by U dash is equal. Mass of carbon 12, mass of carbon 12 cancel. In the numerator, it's 1 by 12. In the denominator, it's 1 by 24. So it's going to be U divided by U dash is equal to 2. Or I can say U is equal to 2 times U dash. U is equal to 2 times U dash, right? U is equal to 2 times U dash. I got the relation between U and U dash. That is my first step always. Once I get the relation between U and U dash, what is the next step, my dear students, which I'll be doing? I'll be just writing a statement. Statement is molecular mass of carbon dioxide. What is the molecular mass of carbon dioxide as per us? As per U, how much that is? That will be 12 into 1 plus oxygen is 16 multiplied by 2. The value comes out to be 44U. This is the molecular mass of carbon dioxide as per our scale, which we have chosen. As per U. But people, are we supposed to calculate the molecular mass of carbon dioxide as per U or U dash? I want to calculate the molecular mass of carbon dioxide as per U dash, right? So this 44U I can write as 44 multiplied by 1U. And instead of 1U, what can I write? Instead of 1U, I can write 2 times U dash. The value comes out to be 88 U dash. So this is going to be the new molecular mass of carbon dioxide. This is going to be the molecular mass of carbon dioxide as per U dash. This is going to be the molecular mass of carbon dioxide as per the new scale which is given to us in the question. I believe this is clear to everyone. Yeah? I believe this is clear to everyone. Perfect? Perfect, people? हाँ जी, मैं सही में बीमार हूँ. मुझे जुकाम खांसी होगी. That's why my voice is slightly different. Not slightly, it's a lot different. Perfect, guys. So this is the new molecular mass of carbon dioxide as per the new scale, as per U dash. Now, what is the second question? Calculate the actual mass of carbon dioxide. My dear students, few minutes back, I gave you one statement on changing the standard. On changing the standard. I'll give you one more question. Just wait. I'll give you one more question like this. Right? I'll give you one more question like this. Just wait. See, guys. Few minutes back, I gave you one statement. Statement was on changing the standard. What happens to actual mass? On changing the standard, actual mass does not change. Actual mass of carbon dioxide is how much? 44 into 1.66 into 10 raised by minus 24 grams. It is never going to change. Change the standard, change it to anything. Actual mass of carbon dioxide will remain the same. The mass of one molecule of carbon dioxide in grams is going to remain the same always, whatever standard you are going to change. Okay? Perfect? Yes, I am from Kashmir. I am from Srinagar, J&K. Perfect, people. I am giving you one more question. I am giving you one more question. Let me see if you can solve this or not. If 1U is defined as if 1u is defined as 1 by 36th of the mass of carbon 12 atom, 1 by 36th of the mass of carbon 12 atom, calculate the molecular mass of glucose. Calculate the molecular mass of glucose as per the new scale. As per the new scale. What is going to be its answer? Can you check it out? Can you check it out? Can you check it out, people? Quickly in the chats, can you check it out? It's a simple one though. No, today there won't be any class for Phoenix. Done? Majority is coming up with 540 U dash. I believe the answer is correct. Let's check it out. So my dear students, what can I do over here is, say, first of all, how do we define 1U? 1U is defined as 1 by 12th of the mass of carbon 12 atom. 1U is defined as 1 by 12th of the mass of carbon 12 atom. And as per the question, 1U dash, how do we define it? It's defined as 1 by 36th of the mass of carbon 12 atom. 1 by 36th of the mass of carbon 12 atom. I'm calling this equation 1. I'm calling this equation 2. If I divide these two equations, for example, equation 1 divided by equation 2. Equation 1 divided by equation 2. It's going to be U divided by U dash is equal to 1 by 12, 1 by 36. So I can say U divided by U dash is equal to 3, or I can say U is equal to 3 times U dash. U is equal to 3 times U dash. Since, people, you got the relation between U and U dash. And if you got the relation between U and U dash, can you tell me what is the molecular mass of glucose as per your scale, as per you? As per you, it's going to be 12 into 6 plus 1 into 12 plus 16 into 6. The value comes out to be 180 U. But do I need to write the answer in terms of U? No. I need to write the answer in terms of U dash. So it's going to be 180 multiplied by. Instead of this U, I'm writing 3 times U dash. The value comes out to be 540 U dash. This is the new molecular mass of glucose as per the new scale, right? Am I clear, people? Am I clear? Now, if I ask you what is going to be the actual mass of glucose, I would say actual mass of glucose is going to remain unchanged. It's going to be still the same. 180 multiplied by 1.66 into 10 raised power minus 24 grams. Okay? All right? 493 in this year's NEET UG is really not the bad score. It's not the bad score, no. Okay, it's not the bad score. So people, tell me whether these two terminologies are clear. Atomic mass and molecular mass. Can you let me know in the chats quick? I think this much is enough for today. Because my throat is hurting. I'm not well, basically. Okay, there's cold cough. All right. I believe all the things, whatever we discussed till now, every single thing is clear, right? And you, regarding your syllabus completion and all on YouTube, we'll be completing it. Don't worry. In 3 to 4 months, I'll be completing your every physical chemistry as well as your inorganic chemistry. Just do one thing: be the part of Telegram group as soon as possible, because on Telegram I'll keep on updating you about all my sessions. Okay. And right after this particular session, I would want your comments on this particular video, and let me know people whether you like the session or not in the comment section. Yeah, perfect. With this, I'll be taking a leave. You take care. God bless you all and love you all. Asal Gurno, side